Hello, my name is Mark, and in this video I want to talk about short journey to reverse engineer this label printer. I am using it to print labels. It helps to keep my stuff organized. Unfortunately, this concrete model supports only control via mobile application, while I want to use PC to send some text for print. It would be much easier to copy-paste component part numbers rather than enter them manually. So that's why I dumped Bluetooth traffic between my Android phone and device and started to analyze it. Before starting to interact with printer, I need to enable HCI lock. It is Android feature to dump Bluetooth packets on phone side before encryption. Application is not that complex. You can see some strings, serial number and a firmware version. They would be useful later. Also important to know that you can send any bitmap, not only text. Now we have some dump on the phone. So let's download it to the PC for analysis. It could be done via adb command. After retrieval of the log file, we can load it into Wireshark, special tool for traffic analysis. There is two non-compatible kinds of Bluetooth protocol, Bluetooth Classic and more modern Bluetooth Low Energy. At first we need to determine what version is used by device. By just scrolling through dump, I noticed clues of both variants. There is logs for Bluetooth Low Energy commands and mentions of a serial port profile, which is part of Bluetooth Classic stack. But if we look closely, we can see familiar strings inside SPP packets, so I conclude that we are working with classic version of Bluetooth. Let's filter our dump to see only data packets. Great, now we can see some sequence. Phone sends some packet and printer replies back with response. Time to replicate that basic communication to check if I am right with my assumptions. Looks like that there is no timestamp or sequence number in the payload, because it is so short, just 4 bytes. So we can easily replay packets to mimic application request. I have not found any native commands in Windows 11 to work with Bluetooth Classic devices. So I am using third-party Bluetooth command line tools. After pairing with target device, virtual COM port appears. I am checking device parameters to find our connected printer. We can find target device by comparing ID and Bluetooth address. Then we can use that COM port to interact with printer. Let's send payload from dump that causes a response with serial number. Wonderful! I am moving in the right direction. Let's return to Wireshark. I need to find out how to send image bitmap to be printed. Luckily, it's obvious from the dump. We have big blobs of data split into several chunks. In application, I can control length of printed label. By default, it is 35 mm. I printed the same image with specified length as 36 mm to check difference in payloads to see some variadic fields, control sum, timestamps, data size, or any other changes between two print requests. And to my surprise, I saw just 1 byte difference. It means that I need just properly encode image pixels and we are done. Next step was to send different byte patterns to determine how image is encoded. It was quite straightforward. First chunk of bytes with fixed size describes first column. Second chunk of bytes describes second column, and so on. I noticed only one strange detail. Order of pixels in bytes for the column. First bit relates to the bottom of label, while usually it should be top pixel. After dozen of test prints, I had enough information to build payload by my own. I am using JavaScript to render text to the image and then to send it to printer via virtual COM port. First attempt was almost successful, just wrong order of bits in the byte. After fix, it worked flawless. It could be a valid question. If I have working Android application, why I just don't decompile it to avoid traffic analysis and be able to use source code of application to reverse engineer protocol? Answer is that unfortunately I was not able to correlate packet structure from decompiled source code with dump. It made no sense to me. Of course, somewhere there is encoding logic, but I could not find it from brief look. And communication was simple enough to understand it without studying application logic. Yes, it was quite trivial and quick reverse engineering session, but I still hope that it was helpful for someone to see tools and methods that could be used to perform such tasks. Thank you for watching and see you in the next video. Bye!